Okay, this is office hour. Right now is about 1:37 p.m. May 12th. So we have two kind of questions for this particular office hour that I would like to share. I have a bunch of students here with me. The first question I would like to address is about midterm, about what is a pseudocode and what is a communication chart, right? Okay, so first I like to bring my, let me see, do I have a folder for midterm? Okay, I think I have it. Okay, this is the folder. You can see that this is the continuous the project. So for example, what is a pseudocode? A pseudocode, for the purpose of midterm, is really just the .h file. Okay, for example, if you take a look at the record .h, and by the way, I'm going to share this folder continuous so you can actually see what's in there. So, so for example, this one I have a record definition over here, but mine is a little bit more complicated than I showed earlier because I really is trying to give you a runnable version of the whole situation when we talk about the continuous. But the idea of a pseudocode is like this. You basically declare what is your class, and also what is the member and what is the function, the member function. You don't need to provide the implementation of the member function because that's the detail which somehow from the name of the function, you kind of can give a hint about that particular function needs to do. That's fine. So you can actually put whatever information in the name itself. That will be helpful for the.
So the names will be enough on their own.
Yes, you can define the name yourself.
Okay.
Yeah. Is that okay? So that's the pseudocode I'm talking about. And of course, if you want to, if you think that your pseudocode particular function is quite complicated, then you are not sure that this is exactly you can the best way to convey just with a name. So you can actually in the curly bracket, you can actually write a little bit English description about what this function is supposed to do.
Comments could work?
Yeah, comments will work. Comments or whatever. Yeah, you can write it. By the way, there's no syntax you need to worry about. Okay, pseudocode is just the information.
Do you care about like the include files that we put?
Well, just the name. For example, you can say I include MP3. Okay, by the way, I should say there are multiple ways you can represent include file. You can actually say, for example, in this case, I use inheritance. Yeah. I said class record public virtual core, right? So that means I have inheriting from core that indicate that I need to have include core.h, for example.
Oh, okay.
So you can use different way, but I will say I'm not too worried about include file because your class hierarchy already represent your inheritance relationship. So if as long as one of this place you represent the information related to the include, that would be fine. But I do want to say, don't go into too detail. For example, you say, well, how is MP3 is going to convert it? That's too much detail. To just at high level that you can actually show that your idea, that would be enough. Think about you only have 15 minutes to do the whole thing.
Because things like maybe I want my program to do some functions, but I don't know what include files will let me do that.
Oh, don't worry about that. You just say, I want to have a function. This function will do X, Y, Z. That's enough. Okay.
So in that aspect, I don't have to worry about the include functions. Like I can just like come up with a random.
Right. You can come up with a random function to do that.
We mean wait, function or I meant library name.
Library is fine. It's a library. You don't have to say. Let me give you an example. Since I'm here,
so I can come up with a random library name right now.
Yeah, you can come up with a random library name. Make a lot of assumptions. For example, let me actually show you what I got here. I was the other day looking for the code that actually can play a sound. It's a C++ code. Let me see if I can have here. I remember I did something. let me see. Yeah. For example, you probably see that this is actually a Discord API, which is a D++. Discord API, D++ is the C++ API implementation for accessing Discord information. And over there, they have a lot of interface for streaming MP3 file.
Okay.
So you don't need to mention this. You just say, hey, there is existing, because today, typically, if you do a Google search, whatever function you know, there must be there something. Okay. Yeah, you have a question?
So, like, say, like this class right here, inherited public record. Do I need to rewrite like what's in records, like JV time when is already in here? Do I have to rewrite it, or can I just assume that it's inherited through that?
Yeah, you can assume it's inherited.
Okay, so I don't need to rewrite it. Okay.
Yeah, you don't need to.
Okay.
Yeah. Yeah, try to just think about this is convey a high-level design idea. Whatever you have it. I mean, just be fair. If you didn't write it, I actually mark you by -2 point. Just rebuttal with me. Okay, just come to here to explain the concept, and then it's recorded. By the way, even what I'm saying right now.
Yeah.
Okay, it's a big deal. I would think that I really, for the midterm, I will encourage you to do the best you can. But if there is anything like this kind of little detail, we can always talk about that.
What about the communication chart then?
Yeah, I'm going to talk about that. So that is a pseudo code, right? You asked 2 questions, one is pseudo. So let me actually go to the communication chart. Okay, so this is the file that I use in the, I think last week in the lecture. I will share this file. Okay, by the way, did I share? I probably already shared in that folder. I might not share the update. So this is the communication chart. So communication chart is essentially in the pseudocode, you and the class hierarchy, you define the class, you define the member function. Communication chart is really try to put all the pieces of puzzle together. So essentially saying that, okay, I have an object, Felix, Davis Police Department, another object. Then basically I'm trying to indicate that what the member function was called to actually to kind of form the scenario. Communication chart is representing a scenario. It's not meant to be exhaustively represent every single scenario. But it represents one scenario to help people to understand what's going on. For example, over here, I only represent with this 2 chart is basically say, I want to talk about when I receive an alert, how do I actually get consent? So I actually make a mistake. This should be Jonah. Consent request. Okay, so you can see that in this picture, the Davis Police Department is an object. I'm assuming there is an object called Davis Police Department, and Felix is another object. So Felix has a member function called alert that is going to be receiving alert from other entities. So in this moment, you can see that the object names are Felix dot alert time and location. So it means that the Davis Police Department is sending this over here to me.
Wait, what?
Say it again.
So alert is a function of the Felix object.
Yes.
And then it's called by the Davis Police Department?
Right.
Oh, okay.
So think about, for example, when you receive the alert from your smartphone, right? That means, in some sense, that means your phone has an interface.
Okay.
Like an object-oriented interface to receive this notification called alert. And notification, you can represent as a function call. By the way, I should actually mention, this is in general object-oriented paradigm. There's 2 ways I can communicate. One way is called method call. I call a procedure, and that's it. So it means that I'm expecting you actually reply to me at some point about what you're going to do. The other one is called asynchronous communication. It's purely a message. It's sent to you, so it's asynchronous. But in C++, you can do a asynchronous, but not very, very, how do I say that? I mean, for the midterm, don't worry about asynchronous. Just worry about alert coming over here is a message call over here. Okay, so then you can see that once I receive this, before I reply to Davis department with this alert. So this alert is essentially request information about time and that location, what kind of sound, I mean, example that you got. So the thing is that I need, because the sound actually recorded together with my partner, Jonah, so I actually send a request of consent. That is a member function of Jonah to say consent request to Jonah. So let me actually just complete this. Okay, let me actually do this part.
Wait, is the stuff in the parentheses like what the return type, or are those parameters?
That's a parameter.
Okay.
Yeah, parameter. And then you can see that, and this is the request coming back. So I would just say reply. Just say yes. Okay. So you see that this is a reply to yes, that's a communication chart, right? You request the consent, and then this is reply. This is a reply to, if I make it more complicated, that is actually reply to this particular message call.
Yeah.
But with this particular situation is actually clear. That was a reply to that.
The arrows down means like increasing time, right?
Yes,
Okay.
yes. Okay. That's very important point. I forgot to mention, this is the time goes down. So
Okay.
communication chart is representing time sequence. What's your name?
Justin.
Justin, you probably save 200% of the class, because a lot of people, they don't know when I say this, I really appreciate. Yeah, it is, communication chart is representing the time sequence from the top to the bottom. Okay, so after this, then you can see that Felix is going to reply to the police department. And then I'm going to do sound file. Okay, where is my? Then I'm going to say reply, and I'm going to do just some, why this? Okay, some kind of sound clip. Okay, send it back to the police department. So this essentially, you can see that it's a communication chart involve 2 functions and 3 objects.
Yeah.
Yeah.
That makes sense.
So this essentially putting the things together. I think it's like explaining a story.
Yeah.
Right. Okay. Yeah. Okay. That's okay with the, any question with the midterm?
How many scenarios you mentioned? Like one scenario, right?
One scenario will
How
be
many?
fine.
Okay, one scenario.
Oh,
One
okay.
scenario,
Oh, so for communication chart, it's just a scenario.
just a scenario.
Okay.
Representative scenario. Yes, please.
Sorry, quick question. Do you think you could post the NG or link for me?
Sure.
Because I need that one, right?
Yeah. Okay.
Thank you.
Yeah.
And then I just run the /homework server.
Right. Can you wait for a moment, because I'm actually in the middle. I'll do that for you. Okay. All right. Thank you. Sure. Okay. Any other question with midterm? Okay. So now I'm going to switch to homework 4, right? All right. So I'm going to switch to homework 4. So in homework 4, I'm actually going to switch to, I believe is mobility. Okay, so can you remind me what was the question about homework 4 besides JSON to object? What's?
Yeah.
Okay, got it. Okay, the file. All right, so okay, so let me actually give you an example. I'm actually showing on my screen right now. This is, I believe you're asking about ecs36b json.cpp. That's the file that's actually provided as a utility. So let's actually say I want to store a JSON. I want to store a JSON. So of course you can actually decide, well, what is the detail for you to do that? And one of the facility I actually provide is over here on the screen called my, sorry, let me go up. It's called my JSON to file. Okay, there is a file called my JSON to file. So what is my JSON to file? It takes two parameters. The first parameter is the file name you would like to save. And the second parameter is actually the JSON object that you would like to save in a file. So let's actually write a very simple program to show you how to use it. Let me do this. Did I compile this program? Let me just compile it, make sure everything is okay. Okay, everything is good. So I'm going to use which program? I'm going to use mobility underscore dump as an example. Is this homework 4? Okay, never mind. Okay, I'm going to use this. Okay, so this program is called mobility dump, but what I'm going to do is I'm going to neglect all the whatever the internet connections. So I'm going to get rid of this line particularly because this line is actually going to is trying to really contact the server. I don't want to contact the server. I just want to deal with show you how to use my JSON to file. Okay, JSON to file. Okay, so let's actually first take a look at that, and I have a JSON value over here called my v. So I'm going to create some dummy JSON. So I set name, I would say class name is equal ecs36b, and my v, the concern is actually equal to homework assignment number 4. And then I said my v, number of students show up today. Number of students show up today is, how many students do we have in this room right now? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a 9 students. So I'm going to write a 9. Okay. So you can see that I'm actually produce a JSON. Let me actually just print it out. Print this JSON out. Okay, if you take a look at this, I just create a JSON, then I print it out. But now I want to actually print out to a JSON using the program called JSON to file. So I'm actually going to do an integer RC, which is I want to see the return code. By the way, what's the interface? Sorry, ecs36b JSON CPP. It's my JSON to file. Okay, it's return an integer. Great. Okay, RC is equal to my JSON to file, which the first one is a name. So I basically just say the file name is dot slash say okay, office hour dot JSON. Okay, so that is a file name I'm going to save. It means dot slash means current directory. I'm going to create a file. I'm going to create a file called office JSON. And then the second parameter, remember, it's a pointer to a JSON value. So what is my v? My v is a JSON object. So I want to have a pointer. So pointer is address. So it looks like this. Okay, that is basically the code to how to use my JSON to file. The file name and the pointer to, or address, pointer and address in C or C++, they're the same. Okay, so I'm going to compile it. Oh, what did I do? Okay, does not allow conversion to character star. Okay, fine. Okay, there is a little problem because I'm actually taking, I guess this actually confused people because I have to do this. Okay. So I'm going to do a std string. I call the s is equal to /office hour .json. So this is the file name that I'm going to save. So over here, I want to actually make sure it's actually compatible with the C. So I do s.cstr. I thought this should work. Let me try it. No match function. Okay, that's because I didn't have. Did I have that? Wait a minute, I already have that. First argument is we lost the constant. You know what? I decide to do this differently. Let me do this differently. It's just always the compatible between C and C++ pointer is getting theirs. Okay, I'm going to do this. I'm going to do character buffer 128. And then I'm going to do sprintf. I'm going to do this. It's probably easier. %s to the s. Okay, I'll just do this. And over here, I will just say buff. Let me see if this will work. I have always have this problem. Let me see. Cannot pass. Why is s? That's stupid. Okay, sorry about that. I'm actually going to. What is the best way to do this interface? You know what? I'm going to do this. Just say sprintf buff /office hour .json. Okay, I'm going to get rid of this line. I don't need this anymore. Hopefully this will resolve the issue. Okay, that is just warning. That's okay because I'm using sprintf instead of smprintf. I'm kind of in a rush, so I didn't fix that. Okay, so now I'm going to run the program. This program is called mobility dump. So I'm going to call mobility dump. Okay, so it's actually, you can see that it's actually printing the, okay, let me actually remember this output. This is actually produced by the stdcout as print, but it also create a file called office underscore hour .json. So if we go to office, so that is actually the file it produced. Okay, so that is an example. I actually realized what mistake I make. Let me just fix one thing. Let me just do this. Man sm print. Make sure that constant char real format size t. Okay, good. Okay, so let me actually just get rid of that warning. I think I know how to get rid of that warning. Over here, I will use sn printf. Over here is just st string length /office hour .json +1. Let's try to see if this will get rid of the warning. Yeah, okay. So I'm running this again. Okay, it basically, this is the output, standard output from the program itself, but also stored in that file. Okay, so that is JSON to file. So now I'm going to go the other way, which is a file to JSON. Okay, So how do I do file to JSON? Let's actually look at the code itself again. Okay, starting here, and let's go to ecs36b JSON, and then I have another program called my file to JSON. Okay, you take a look at this program. This program is basically the same interface. Is taking the file name, but then it's going to put whatever the incoming file and convert it to JSON and put that in this. So this is a from to to, okay, from this file to this JSON. So how do I actually print it? How do I actually call it? So over here, we just did this part, right? We just did this part. We have this. Okay, so now I'm going to have another JSON object, JSON value. I call it another my v. Okay, this is another one. Is nothing over here. So I'm going to actually call this. I say RC is equal to my file to JSON. And what's the file name? Let's just use the same file name, which is above. Okay. And then the pointer is m. Sorry, I call it another my v. Okay, so this is basically wait a minute, why I have one extra parenthesis. Okay, fine. So when I call this, then another my v should be the same as the result. So I'm just print it out. How do I print it out? Using the c.out. So I come over here, and then I basically say another my v. Okay, so let me actually do something. Let me actually do something. I will sleep. First, I want to show you this. Let's just make. Okay, you can see that it's actually have the same content, right? It basically just read this, save in the file, and then from the file, it actually put it in. Okay, so let's actually play a trick. I just want to have fun to do this. I'm going to let my program, I hope they allow me to do this. Let me see. I want to say sleep 30. Would this be okay? Do they actually allow me to do sleep in C++? Yeah, it doesn't. Let me see. Man, sleep. Man, 2. Man, how do I look at system call? All right, forget it. Oh, I know what I want to do. Let me play around just for fun. I want to do something. I said character C, and then S scanf percent C MC. I want to actually read a character from the so I can actually stop it. Let me make okay. So I'm going to run this program. You see it is actually stopped here. So let me do a trick. I'm actually going to come over here. I want to use editor to modify this file office hour. And I change this to homework 5 and change this to 200. Okay, so I'm actually modify the file while I'm running the program. And then I hit it. You see that right now, it see the change. Okay, so it's basically I can actually modify the file. If I can modify the file, means another program can also modify the file. Then that's two functions. You can actually just convert it to JSON, convert it to a file, and then read it from the file. Okay, does that answer you guys' question?
So the entire process happens inside the JSON to file function.
Yes. Yes. I mean, I gave you the code. You can actually take a look how I do it.
Yeah, I wasn't sure because I couldn't find a file where we actually call these functions, especially like the JSON to
Uh-huh.
object.
Uh-huh.
And how do we call that function again? The JSON to object.
Okay, there's a few things about in terms of the programming language, this is the way to call it. Okay, you see that my JSON to file and my file to JSON, right? This two line. It show you it's the same interface,
Okay.
the file name and the pointer to a
Okay, I thought
JSON.
we have to do the function and okay.
No, it's given to you.
Okay.
You can just use the function to do it. It's actually very handy. But the thing is that if you have time, take a look inside the code. It is actually you will learn something by
Gotcha.
how
And-
it's not that long. Yeah.
And you hard coded those things like class name and everything.
Yeah. Right.
If you had like a record,
Yeah.
With
If you
object?
have a record, right? If you have a record, you say if you let me just give you an example. If you have a record R, okay, then you should do R, you should do inside the you should say actually my V is equal to R dot dumped to JSON. Right?
Okay.
If you have a record object, it will have a dump to JSON.
right?
And then so you basically put all the content of that object into a JSON format, and then you actually save it in my
And
V.
in the file.
Right. No, this is just a JSON, right? And then you use my JSON to file to save that to a file. You see, I mean, let me explain to you. This is just you have a record object, right? And now you basically dump the content of the object into the JSON format, right? That's what you're doing. And then you basically over here, you actually save the JSON, which is represent the content of that record into a file, right? Okay, so now it's interesting. So now then we basically, in this line, we basically reload the content of the object from file, right? But in JSON format. All right, so now this is the last part. Now we come to the JSON to object. So JSON to object, then essentially you need to have a Boolean, say B is equal to R dot JSON to object. And then inside here, you just put my V. Oh, sorry, this should be another
JSON.
my V.
And what's the type of that?
Another my V is here, JSON value.
Oh, gotcha. Yeah.
Right,
Okay.
because another my V is just you got that file back to the JSON. Now you're actually converting the JSON to the C++ object. So when we say JSON, it really means is a JSON object, but that's not what we want. We want C++ object. So the program, the virtual function JSON to object is converting a JSON format into going back to the options.
And how will you know it's working? What are we going to
Okay,
see?
it's great. So the way to work, how do you actually know it works is you can do the following. Because if you have the R, right? Let's assuming this is R. Actually, let's actually not call it R. Let's call it R another. Okay, I want to create another object, right? So now this become R another. So how do you actually know it works? That's fine. I'm actually going to have another JSON object. Sorry, JSON. Yeah, that's right. I call it JV2. Okay. JV2 is equal to what? R another dot dump to JSON. Okay. I actually created another object, and then I actually how do I know it's the same? I basically just dump it again. And that JSON should be equivalent to the original JSON. I save in a file, I actually do that.
Just
So-
copying everything into that JV2 value.
Let me actually clean up this part a little bit, okay? Because I actually kind of mixed with a lot of stuff. So let me actually clean that up a little bit to use in the explanation. So I'm going to, this is the code I just copied, but I'm going to remove some of the stuff which is irrelevant, okay? This part is irrelevant. I will call this is the original record object. Okay. And I'm going to get rid of this as well because this is no, I cannot get rid of it. Oh, I can get rid of this one. And I'm actually going to write this part. Yeah, that's fine. I'm just going to store that. I will call this record R JSON. This is the record R JSON. Okay, after I've done this, I'm going to get rid of this two line. They're not related. Okay, so now let's see what happened. So I try to annotate each of the line. So up to here, I have a record object, record C++ object called R, okay? So up to this point. And then what I have here is now I have a record JSON object called my VR. Okay, let's actually change the name called my VR. Okay, so this part, I'm just basically now you have two representation of the same object. One is called R, it's a C++ object. One is my VR, which is the JSON representation of R using dump to JSON. So the following is just decide what is the name of the file I like to save. Usually this part is you decide how you're going to represent. For example, you might have object identity to include it in the file name, but that's actually, it's a different business. Okay, so now you can see that my file name for the object R or my VR what is called myvr is actually stored in buff. Okay, so I store in buff. So this line up to here, I actually store it. So here now I save the JSON object my VR to, sorry, this part need to be my VR as well, to that whatever the file buff. Okay, so I store it over there. So now you can see that you have a file with that content. Okay, so now it's done already. I'm going to do the, so now I'm going to do the reverse direction. Basically, I want to get it from the file to the JSON. So reverse direction is actually from the file to the JSON and finally go to the C++ record. Okay, that's what we're going to do right now. Okay. All right, so I actually call that the JSON I want to create is called another V. So this is the reversed direction. Hey Shrey, how are you? I'm good.
Hi there. I feel good. Thanks for asking.
No, my computer thought I'm talking to her. Yeah, but anyway, that's okay. So reverse direction is actually going to be, this is a reverse directions JSON object of R. Okay, so I actually get it back. So you can see that this line, next line, my file to JSON basically is saving, converting from that file to the JSON. So at this moment, this line I don't need. At this moment, that we already done file to JSON. This part is done. So the remaining is basically do the other part is JSON to C++ record object. Okay, so now I actually first, in order for me to do that, I actually create a brand new record object called R another. This one is brand new, has nothing. Has nothing in it. Okay, so now I'm going to kind of convert to finish the second part such that all the content will be there. So you can see that this function over here is actually calling. So where's R another? R another is this brand new record. Hey Tyler, how are you? Okay, so I'll talk to both of you at 3 o'clock. Okay. Okay. So R another dot JSON to object. Okay. So this is the function JSON to. So what's the parameter of JSON to object? It's just another JSON. It's a JSON value object. Okay. So now you have this. After this, you're done. Your object. So at this moment, if you didn't change anything else, so the content of R and R another should be identical. Right? They should be identical because I do this part. You see what I'm doing is just converting 3 format. C++ to JSON to file, and then from file to JSON to C++. Okay. So they should be identical, but how do I know they're identical? The best way to do it is I'm actually just calling this JV2, which is the JV2 is equal to R another dump to JSON, and JV2 should be identical to my VR. Because this is R.dump JSON over here, and this one is R another dump JSON. So what you can print it, you can compare. Basically, my VR should be identical to JV2. So your original question is, how do I know it works? My JSON to object works. If this process, you see that I call JSON to object here, right? I call JSON to object over here. If that program is implemented correctly, this two should be the same. Let me give you an example why they could be different, because you make a mistake is that, for example, in the JSON to object, you forgot to convert a particular attribute from the JSON back to your C++ world. Then when you dump to JSON, that value is not there. Then you will see that either that attribute is missing or that the value is not being set correctly. Okay, so that's how you actually do that. Of course.
So in homework 4, I supposed to use the code we wrote for homework 3 in homework 4 to create like the objects, like the record.
Yes, you essentially use your homework 3, but you can modify your homework 3. Okay, for example, you can make some improvement. That's okay. But homework 3, you only have dump to JSON, but you don't have JSON to object.
When we create the JSON object stack from the files, do we put them back in the same JSON objects, or do you want us?
Usually we put in different JSON object. We put it in different record object as well.
Okay.
Because if you put in the same, you might override.
Okay.
So you want to see how that works, but that is just for the testing. The goal of the program, the goal of the homework 4 is to ask you to implement that member function called JSON to object for every single class you have for your homework 3.
And then do you want us to delete the files after we're done like copying them, or do we just?
You don't need to. You don't worry about that. It's not going to be a huge file.
So,
I don't worry about that.
so
Yeah.
homework 4 is basically we use homework 3 to create the records and then create the JSON objects, and then after that we put the JSON objects into files, and then we take the files, make them back into JSON objects, and then we do the JSON to object.
Oh, okay. I have to clarify. I actually didn't ask you to write it to the file. I only say you implement the function called JSON to object. I didn't actually ask you to write to the file.
You do say that you have to save it to the file. It says so in
Did I say that?
Yeah.
I'm sorry.
In the homework, it says in.
Let me check. Let me check what I said. Okay, maybe my bad. Maybe I did. You did need to do that. Thank you for letting me know. Yeah, let me actually check what did I say? I mean, sorry, I forgot what I said. Homework 4.
Homework 4 cancel.
Wait a minute. I think I know what I meant. What do I mean by that? In the homework 3, you need to save it to the file, right?
No,
No, you just
dump it.
You just dump it. Then okay. Okay, that's why I think there is a confusion here. Okay, so
Yeah, that's why I didn't understand if we were supposed to use the functions or
yeah.
to save it.
You want us to dump both the original and then the converted?
Okay, I think at this moment, either way is fine. So if you want to actually write it to a file using the JSON to file and then retrieve it back, that's fine. But if you don't want to do that, you just produce a JSON from dump to JSON, and then you actually be able to successfully call JSON to object, and then into the object, and then reproduce that JSON, dump to JSON again, then the two JV, they should be identical. That is fine. So use file or not use file, I probably messed up about what was in homework 3. That's why I put it there. Yeah.
So then do you want us to like dump the original records, and then after we do like the whole like converting from like files and records and JSON, do you want us to dump the records or the JSONs again?
In order for you to actually compare whether they're the same
So
or not.
then the 8 records, right? 4 from
Yeah, yeah,
before.
that's
4
right.
from-
That's right. That's right. Yeah.
And they
Okay.
should be identical.
Right. That's important. I mean, regardless how you convert it back and forth, they should be identical.
What's the grading criteria?
Grading criteria for that? I think, right, let me see, okay, so for that 2%, you have, say you have, if you actually convert it correctly, and then you actually have the right makefile and also the submission, you got the whole 2%, right? But if you actually have some record which is inconsistent, which means your JSON to object file, then we will deduct partially 0.5% for each of the mistake that you have. Up to, I mean, everything else, if everything else looks okay, means your makefile, your compiler, you should get 0.5% out of that 2%.
How much should we write?
I said less than 2 pages.
But is there like a minimum?
There's no minimum. There's no minimum. I say if you can actually really describe the good information, there is no limit. Yeah.
Can we use like bullets instead?
Yeah, of course. You can use bullet point. You can use whatever you want. You can draw diagram as well. With diagram is excluded from that 2% limit if you want to have a diagram. Yeah, first. Okay. Hi, Mo. You have some question for me? Okay, sure. All right. Any questions?
Yeah, so like my record, where's that? Right here.
Mm-hmm.
They have objects, so JV time, GPS, all that.
Right,
And then so like my dump to JSON, that's like it dumps the objects.
right.
How do I do a JSON to object for objects?
How do you do JSON to object from object to object? Okay,
Yeah.
that's why I want to show you this piece of code. Great question. Let's look at sorry. Yes. Okay. The code is actually in mobility. Let's actually take a look at this. So over here, let me see, what do I have? Okay, message. Okay, Emacs minus NW. I'm just using the example how I do that. So let's actually take a look at message.h. So message.h, it has a JSON to object, right? But it also has some component that is actually an object. It's commutable. Commutable is could be a person and could be a team. Okay, so it's essentially, I'm actually going to kind of recursively to call JSON to object first at the message level, and then to the how do I say that, to the object that inside the other object. Like your case is, in your case is record, then you have JV time, you have person object. In my case is message, I have a person, I have a team, something like that. Okay, so let's actually see how I do this. Hopefully that will help you to understand what's going on. So let's take a look at the message JSON to object. So let's go to message CPP. And over here, you see that I have this JSON to object. And you can see that this first piece of code is really do checking whether you have the right element. So the problem is C++ is mostly compiler time. JSON is 100% runtime. So JSON, there is no compiler to check. So I have to actually check at runtime. So that's why this part is just checking. But let's actually see, after you finish the checking, you see that this is what I did. So when I dump the object, for example, if this is the thing object, so the complication about my example is going to be more difficult than your example, because in your example, you don't have this kind of inheritance situation. Okay, so I have that. So I basically determine it's a thing. So look at what I did. So I said thing, I create a new thing object. Okay, so when I have object, I have to create another object. And then what I did is that I actually insert. I call, you see that now I'm calling the thing objects JSON to object and putting the front part. What's the front part? Is the whole, how do I say that? That part of JSON. In that lecture, I actually showed the JSON format for the front. Hopefully, do I have it here somewhere? Let me see. I thought I save it somewhere. Do I still have it here? Okay. Anyway, I'll try to dig it out a little bit later if you still have a question. So I actually call this function. So all this does is I create an object called thing. It's a thing object. And finally, look at this part. I actually save the whole thing object as a content, copy to the front. Okay, so let me actually repeat a little bit what I did here. Okay, so number one, I create an empty, I would just call it thing object. Okay, in your case, it might be JV time object. Okay, and then I actually call JSON to object on the thing object I just create. Okay, and this essentially, I pass that portion of the JSON, pass the front portion of JSON into the thing. Okay, Okay, so now I have a new object called thing, but it's nothing to do with the current record object I'm dealing with. It's just a separate thing object. Okay, so after I've done that, then finally, if everything is okay, now I actually copy the thing object, its content basically, into this to the front, which is what is it? This to front? This to the front is the whatever attribute front that's actually hosting either a thing or commutable, or in your case, it might be a JV time, whatever you have.
Okay, so should I implement commutable into my program? So
No,
No.
don't implement. You don't.
Okay.
If you implement commutable, it will be really complicated.
Okay.
In your case, let me actually take a look at your.
I tried like trying to do what message did. I just didn't know if I did it right.
But you don't have a message, right? Record, you don't have. Let's take a look at your JV time. Okay, let me take a look at your code. So you create a JV time that looks perfect. Argument when, that's perfect. Yeah, this is good.
Oh, it's right.
That's right. Yeah,
Okay.
this is right. Yeah, you
Okay.
got it already. Yeah.
So like, well, let me make this real quick. Oops. Files of objects. So let me do test dump. So this is like, say my first one.
Right.
Where is record? It's like, so see how in, let's say like thing, I have size and type.
Mm-hmm.
If I go to record, did I do that right? Like thing type and thing size.
Yes, that's
Okay.
correct way to do that.
I don't know why this is who this should be thing. It's like that.
Oh, over here, it should be can you say what is the thing one?
That is, so if I go to record, thing one, like, so I had to like separate like
Okay,
my
all
dump
right,
to JSON.
that's
Thing
fine.
one is just that right there.
Okay, can you go down there? But in the JSON, how do you differentiate thing one and thing two?
What do you mean by that? It's like
Can I look at your JSON? Look at your
like my dump to JSON.
no, the JSON file that produced, yeah, over here. So over here, why you don't have thing one and thing two? You only have a one thing.
So like if I go to like this one, when I have multiple things,
Right.
I have like
Right.
that.
Right. So in this case, you see you have thing one, thing two, and thing three, right? So can you go back to your code? So in the JSON to object.
Yes.
So over here, you should probably have a thing one, thing two, and thing three somewhere, right?
Okay.
Oh, sorry, it should be, yeah, this one should have thing one, thing two, and thing three, right? Then you can actually compare. And then also thing one, the size, is thing one size, what is size? The type of size. Oh, the size is small. Yeah,
Yeah.
right. Okay, that looks good. And in this case, can I go back to your code?
Yeah.
Over here, because this is really a string, right?
Mm-hmm.
It's a string, so string is no longer an object. So you
Mhm.
don't need to actually call JSON to object here. So what you want to do is you just say, this to the thing one dot type is equal to whatever the string. So may I write
Yeah,
it,
of course.
write it down here? Because it's already go down to the basic type, it's no longer an object. So I hope I understand what you're just doing. So I'm going to do thing and no, I don't think I even need to do this actually. I just say this to the thing one. Sorry. Yeah, now your screen is not being recorded. You know what? I'm going to write it down here. Would that be okay?
Yeah, of course.
So everybody can see. Okay, in your case, I would just say this to the thing one dot, that's type, right?
Mhm.
Is equal to, sorry, ARG JV. This should be thing one, I think. Thing one, capital, lowercase, you determine later. And then the second one is type. Okay, this one together. And then dot as string. I just need this line.
Okay. So
You understand what I'm saying? Because this is already, we're already go down to type, right?
Mhm.
We just actually write it over there.
Okay, so I don't need any of this. I just need that one line for right here.
Right, right.
Okay.
Of course, yeah. Of course, you need to check thing type dot as a string.
Mhm.
Over here, because if you do thing, this is equal to thing, it shouldn't be equal to thing, right? Because thing to the type as string, can you go back to your JSON?
Yes.
This type is going to be Android device, right?
Mhm.
So what you want to do is that you want to actually say you need to check whether the JSON that really has thing one,
Mhm.
and you need to check whether the JSON thing one really has a type as a key value pair, and then whether the thing one type is actually a string. So you need to check the three things. That's why if you take a look at my code, I actually did a lot of check. You see that I'm actually checking all this. Let's give you an example. I check whether you have a from, right?
Yeah.
And then I check, oh, you already have this. And then
Yeah.
that's good. That's good. Then that's good. The only thing you didn't check is probably whether the thing type, not just is null, is a string.
Okay.
Because you expect a string, right?
Mhm.
Yeah,
So-
that's the only thing you're
So
missing.
I should add is string to this as well. So I have is
Right.
null for all of them. I have
Right.
is object. So I add is
Right,
string.
right. I mean, depending on the type, right? Because
Yeah.
your type is a string. Yeah.
Okay.
That's the to make sure that your JSON to object can handle things correctly.
So is JSON to object just like check that it can be converted into an object?
It will check can be converted to object, but also it will convert it for you.
Okay.
If it actually satisfy, you see that's why I provide all the checks in front,
Mhm.
because I don't want to have a partial contamination to the
Yeah.
object. I will check everything first. If
Mhm.
anything fail, I don't do anything to the object.
Okay.
Yeah, that's the sense of JSON. Yeah.
So just going on that, use reference to object, right, from and to. Because I actually have a pointer to object in my record. And does the syntax change, or is this the same if I'm using pointers?
But I didn't use
Oh, because commutable and from
okay,
button was-
that's actually the trouble with commutable, and the commutable has a virtual function, so that's why it's actually getting complicated. In general, if I use a reference, use pointer is always okay.
Okay.
In fact, I prefer to use everywhere pointer.
Yeah, they're much better.
Pointer is much more cleaner actually. Yeah, but some people just hate pointer. That's why we create something called reference. Okay. All right. Yeah. Right. How do you print the address? Okay. I will explain today, actually. I will go through that today. So yeah, I just wait for a couple hours. I actually in the sample code, I just didn't have time to finish that part. Yeah. Yeah. Sure.
Jack,
Uh-huh.
is it okay if I show you like what I
Sure.
have?
Sure.
But this is just like general. So I know that in your mobility, this converts like the latitude, longitude to the C++ object.
Mhm.
But what I like did for homework 3 is I have person and the thing within another. Like if you like you can see over here, right?
Right.
person is within who, so I
Right.
have another like
Right,
JSON object,
right,
which is
that's great,
container.
right,
And then the container I set it equal to this, oh, oops, yeah, here. And
Right.
then same thing with the thing. I set a thing container to the what.
uh-huh,
So in that case, how would I kind of go about letting all of these persons become like the C++?
Okay.
object?
Can you actually show me your JSON object again?
JSON object?
The JSON representation of this. You show me the JSON
oh,
represent
this?
this. Yeah. Okay, so essentially we actually take a look at the who, right?
The who.
So what you need to do is that in the who,
Mhm.
that in the this is actually part of the record. So I'm actually going, can I write it here? Okay, so you can actually see that as a record. So let me actually let me actually first tell you that what your JSON looks like. Your JSON looks like who, and then you have a container, which is an object, and inside the object you have person one, and then over here is actually a person object, right?
Yeah.
And then comment, you have person two, and then you have another person object looks like this, right? So
Yeah.
this is your JSON that we try to do JSON to object, right? So okay, let's actually take a look at what we did. So I assuming we don't do the check. The check is already there. Okay.
Mhm.
So the first thing I will do is that I'm actually going to create two-person object because you don't have a object in your C++ to say container. So I'm going to create two-person object. I will call person P1 and P2. So I create two objects, right?
Yes.
And then what I'm going to do is I'm going to do P1 dot JSON to object. And inside here, I'm going to do the value. So it's going to be, I forgot, is argjv, right? Argjv to the who, and then to the yes, and then to the person one. Okay, this one, if I do this, this is going to create okay, if I do this line, you can see that I actually, this should be represent this two. So because who and then person one is actually going to represent this portion of the JSON. And then I basically, because I create an empty person called P1, and then I just say P1.json object. Can I see your record.h?
Yes. Yeah, you'll see the, yeah, right here. I added them all into the record.
Right. No, I want to come over here. So the person is who1, right? So now I'm actually going to do this. I'm going to say who1 is equal to P1, right? And then who2 is going to be equal to P2. Then this I complete. So this two I just created, but now I copy it into that record object.
Okay.
So if you forget to do this, then the who1, who2 is not having that value. So it's a one extra copy, but depending on how you implement, sometimes some of the situation you can actually directly call who1 here. You might be able to do, say, this to the who1, depending on how you implement, whether you're using pointer or reference. This, in your case, I think you can just say this to the who1, JSON to object, argument JV, who, and person one.
And this will, sorry, this will do what again? This will.
So you're asking this line, right?
Yeah.
Okay.
This whole thing. Yeah.
So this line, what it does is that I actually want to, if you think about that, I have an empty record object, right?
Yeah.
I want to piece by piece restore the record object from the original record object, right? So remember the record object is empty at the beginning, means that none of this exists. I'm actually trying to convert the JSON back one piece. So let me ask you, so the first attribute, you have a person who won, right? What do you think the value of who won at this point? So who won is a person object that has nothing, right?
Yes.
Okay, so now I want to write the value. So after I call this to the who won JSON to object with this particular portion of the JSON, after I call this, the who won will have exactly what you have here in the person one. We'll have Felix and the instructor over there. Yeah, so it's essentially, think about that is, I have a blank C++ object. So after I've done JSON to object, it has something for that particular attribute. Okay, and then that's why we have to do both who one and who two, because depending on how many person you have, right? Can do that. Okay,
Thank you.
you're welcome. Yeah.
So do you think you could help me real quick?
Yes, let me turn off the then I will help you.
Thank you,
Okay,
Sorry.
sure. No problem. Sorry, I forgot about you already. Yeah, yeah.